Modalities of virtual beings explores the spectrum of modalities that define virtual beings, from human-inhabited avatars to AI-inhabited and augmented hybrids. It examines the importance of convincing backstories and behaviors in shaping believability and introduces cognitive and neural architectures such as state machines, synchronization, and behavior generation. A sequence of modality diagrams traces development from asynchronous and static beings toward synchronous, real-time, interactive entities, culminating in layered taxonomies of avatars, robots, and virtual beings. This diagram illustrates the progression of avatar control from human-inhabited avatars to AI-inhabited avatars, with an intermediate stage of augmented or hybrid avatars that combine human and AI input. Human-inhabited avatars are fully controlled by people in real time, while AI-inhabited avatars operate autonomously through artificial intelligence. The middle stage represents a blend, where human control is enhanced or supplemented by AI, allowing shared agency between human operators and machine intelligence. The rightward arrow emphasizes this evolutionary trajectory, showing a shift from human-driven to increasingly AI-driven embodiments. This diagram shows the ecosystem of virtual beings, highlighting how virtual influencers, human-inhabited avatars, and AI-inhabited avatars connect to elements of narrative and behavior. Virtual influencers, often asynchronous characters, feed into human-inhabited avatars, which are controlled in real time, and further into AI-inhabited avatars, which include chatbots as a subset. To make these entities believable, they require both a convincing backstory, which establishes identity and context, and convincing behavior, which sustains realism through interaction. The flow illustrates how virtual beings evolve from crafted personas into interactive agents, grounded by storytelling and behavior design that together create authenticity and user trust. This diagram illustrates a developmental hierarchy of AI-driven capabilities for virtual beings, progressing from lower-level functions to advanced cognition. At the base is neural lip synchronization, which aligns speech with mouth movement, followed by neural facial behavior, which generates expressive facial animations. Building on this, neural behavior generation enables coordinated body actions, and neural state machines manage sequences of behaviors for coherent interaction. At the highest level is the neuromodular cognitive architecture, representing a sophisticated system that integrates perception, memory, reasoning, and decision-making, allowing virtual beings to operate with autonomy and adaptability. The structure shows how incremental neural modules stack together to create increasingly lifelike and intelligent digital humans. This diagram, titled Virtual Being Modalities 2, categorizes virtual beings into two main types, virtual influencers and VTubers, based on how they present and interact. Virtual influencers operate asynchronously, including static or pre-produced content such as posts, images, or scripted videos, while VTubers are synchronous, performing in real time through live streaming and audience interaction. Between these poles lies faux interactivity via legacy techniques, which creates the illusion of live interaction but is actually pre-scripted or carefully managed. The overlapping circles highlight how these modalities can blur together, forming a spectrum from static, non-interactive content to dynamic, real-time engagement. This diagram, Virtual Being Modalities IV, organizes virtual beings into three main categories: static avatars, human-inhabited avatars, and AI-inhabited avatars, including chatbots, while aligning them with modes of interaction: asynchronous, faux synchronicity, and synchronous. Static avatars typically function asynchronously through pre-created or static content. Human-inhabited avatars operate with faux synchronicity or controlled interaction, and AI-inhabited avatars enable real-time synchronous engagement. To be convincing, these entities require two key elements: a backstory, which provides narrative context and identity, and behavior, which ensures believable interaction. The arrows show how backstory and behavior together contribute to credibility, helping virtual beings resonate with audiences, regardless of whether they are static, human-driven, or AI-driven. This diagram defines the broad category of virtual beings, which encompasses three subtypes: static avatars, human-inhabited avatars, and AI-inhabited avatars, represented here as virtual robots. Static avatars are the simplest form, existing as non-interactive or pre-rendered entities. Human-inhabited avatars add a layer of interactivity through direct human control, such as VTubers or performers operating digital characters. AI-inhabited avatars, or virtual robots, function autonomously, generating their own behaviors and interactions without human operators. By situating all three within the larger circle of virtual beings, the diagram emphasizes that they are variations of the same overarching concept, distinguished by how they are inhabited and how much autonomy they possess. The slide Virtual Being Modalities V shows how virtual beings range from static avatars that are non-interactive and asynchronous to human-inhabited avatars like virtual influencers and VTubers that create pseudo-interactive or synchronous experiences, and finally to AI-inhabited avatars and virtual robots that operate interactively and in real time. It positions these modalities along axes of interactivity, non-interactive, faux interactive, interactive, and temporality, asynchronous, pseudo-synchronous, synchronous, while also framing them within broader concepts of cyborgism as virtual augmentation and virtual cyborgism as phygital hybridization, illustrating the progression from simple representations to autonomous, AI-driven agents. This diagram depicts the internal structure of a virtual human, organized within a cognitive architecture that coordinates different subsystems. At the top, a state machine manages decision-making and flow of actions, linking to both the behavior realizer, which controls nonverbal communication such as gestures and expressions, and the dialogue system, which manages verbal interaction. The dialogue system further connects to RPA, robotic process automation, enabling automated execution of tasks and responses. Together, these components ensure that a virtual human can both converse and act in ways that appear coherent and lifelike, with the state machine orchestrating interactions across verbal and nonverbal modalities.